All right, example 2 from our Pythagorean theorem, section 8.6. We have a set of 3 whole numbers that can be the lengths of the sides of a triangle, of a right triangle, is called a Pythagorean triple. So if 3 numbers can form a right triangle or be side lengths of a right triangle, those 3 numbers together are called a Pythagorean triple. And we're going to decide if the numbers 7, 22, and 28 are a Pythagorean triple. So we're kind of testing the converse of the Pythagorean theorem, that if a triangle has side lengths of a, b, and c, if a squared plus b squared is equal to c squared, then the triangle is a right triangle, and therefore a, b, and c are called a Pythagorean triple. So we're kind of working backwards here. We've seen kind of taking a triangle and finding a missing side length to determine what it needs to be a right triangle. Now we're given 3 side lengths and asked, is it a right triangle or not? And then if it's not, we're going to decide whether the triangle is an acute or obtuse triangle, meaning if there's not a right angle there, then that right angle would either need to be smaller than 90 or larger than 90. And then we're going to decide what that looks like and what the properties and the inequalities for that is once we've decided if this is indeed side lengths for a right triangle. So let's test that first. Let's just see, do these work in the Pythagorean theorem? Because if they do, then they're a right triangle, and we can move on. So I'm going to call C 28. Why? I have to, because if this is a Pythagorean triple, if these are side lengths of a right triangle, 28 has to be C, because C is the longest side, C is the hypotenuse, and 28 is clearly the largest number of the 3. So if these are side lengths of a right triangle, 28 has to be C, and then A and B are interchangeable. Doesn't matter which one is which, but I'm going to call B 22 and A 7. I want to switch those around, it's fine, but C has to be 28 because it's the longest side. So let's plug these into the Pythagorean theorem. 7 squared plus 22 squared will need to be equal to 28 squared. Again, that's the case if these are side lengths of a right triangle. Do our exponents here. 7 squared is 49, 22 squared is 484, and 28 squared is 784. Then we add 49 plus 484, and we get 533, and that is not equal to 784. So what this tells us now is that these side lengths, 7, 22, and 28, do not form a right triangle. So 7, 22, 28 those are not a Pythagorean triple. They cannot make a right triangle. So we have to now decide, well, if it's not a right triangle, what kind of a triangle is it? Is it an acute triangle that has all acute angles, or is there an obtuse angle in there with the side lengths once we make them? So we kind of have to modify the Pythagorean theorem a little bit, and that's related to this, is that if a squared plus b squared is less than c squared, if this value is less than c squared, then the triangle is an obtuse triangle. And if a squared plus b squared is bigger than c squared, then the triangle is acute. So the angle that would be the right angle becomes acute if a squared and b squared are larger than c squared, and that right angle would be obtuse if a squared and b squared are less than the longest side squared. And we look here, 533, this is a squared plus b squared. That is not equal to 784. 533 is less than 784, so we're looking at this instance here. So a squared plus b squared is less than c squared, so therefore this triangle is an obtuse triangle. We can make a triangle with these 3 side lengths, and that triangle will be an obtuse triangle, meaning we will have an obtuse or larger than 90-degree angle in that triangle.